Hi, everybody. Here is some information to help you complete the activity called helmet physics. So you're going to be looking at a data set, and we look at data in science because that is what scientists do, and that's what we all do in the world to figure out information and to make decisions. So that's why we're spending time using these data sets, the TUBA data sets, and this one's for helmet physics. So these data were collected by simulating the impact forces to NFL players' helmets during in-game collisions. These impacts were simulated in 4 different locations on the helmet: the front, the temple, the side, and the rear. 2 different helmets were tested. One commonly worn by NFL players, which is helmet 1, and a new experimental helmet, helmet 2. So they're seeing, is the new helmet better or is the older helmet better? The acceleration of the head was measured, and risk of head injury, called the Severity Index, was also calculated. These simulations were compared to average NFL game impacts resulting in concussions. This data is important because of increasing awareness about the potential for concussions in football and other high-impact sports, and concern for the long-term mental and physical health effects of concussions on athletes. New helmet designs which reduce the severity of impacts are one way these concerns are being addressed. Accurate ways to measure the effectiveness of a new helmet design is needed. Those are needed to protect athletes from concussions and other brain injuries. And your end of unit assessment is about how to design something to help prevent or lessen sports injuries. So you might choose helmets, you might choose something else. But everything we've been studying about forces and motion and collisions will help you do that final project, which is the next thing we're going to be doing. So let's look at the data here. First of all, it's always good just to play with this data. Even when I look at this, I'm like, what does this mean? Until I start just dragging and dropping and seeing what happens. So feel free before you start the actual lab activity to just drag stuff around and see what it does. I see helmet type is here. I tried putting it in different places just to see what it looks like in those different places, what the data, the dots do. And I found that I liked it best over here on the right, where it showed me the 2 different colors for helmet types. So helmet 2, which is the new experimental helmet, is purple, and helmet 1, the current NFL frequently used helmet, is helmet 1, and that's in green. Okay, so helmet 1 is in green, helmet 2 is in purple. Now let's put some other information here. Down here at the bottom is the x-axis, and over here on the left is the y-axis. So you could pick any of these you want. We talked about that severity index was the potential for injury. So you could put that in either spot and see what happens. And then we want to know when severity, right, when the injury is really high, what was the other factor? So my other choices are where the helmet got hit, how much velocity came at the helmet when it got hit, so meters per second, so that's how fast it was moving, the kinetic energy of the impact, and change in velocity. This is the change in speed of a player's head after the impact. So if the player was going this way and he got hit, did he go faster? Did he, go a different direction, slower, faster? So that's what change in velocity will measure. So I'm going to pull impact location. Remember we said it tested impact on the front, the back, the side, and the temple. And so that's what impact location is. So now I put impact location on X, and you can see those locations are down at the bottom: front, rear, side, and temple. So depending on where the helmet with impact happened on the helmet, you could see how the severity of the injury, potential injury. Okay, they didn't hurt people to collect this data, but they could see what the possible severity of the injury could be. So as you look at that, you'll notice that here on the front, and as I click them, that's what becomes darker. So if I click front, then front gets darkened and the rest kind of go light. If I unclick it, then they're all the same color. Okay, so you can see where is the most like severe injuries happening over here on the temple. Okay, that has the highest severity impact index. Sorry, the highest severity index. So the most injury potential is on helmet 2, on the temple, and so that's some information we have there. Now, let's click reset. This is the reset plot here, and let's follow the instructions on the activity. So it says, click reset, which I just did. That's the reset button. And I reset the investigation. Click dot for the type of way that we want to display the data. We want a dot, scatter plot, dot graph. And then we're going to drag change in velocity to the x-axis. So here's change in velocity. And I'm going to drag it down here to the x-axis. Now drag severity index to the y-axis. So there's severity index. Drag that to the y-axis. And my helmet type should be on the right. Okay, and again, helmet 2 is in purple. That's the experimental helmet. Helmet 1 is in green. Okay, so now we have our information. Next, the instructions on this lab say choose least squares line under stats. So here's stats. And if I go over the second one, it's got the 1 dot over a line with 2 dots. That gives me the choice for least squares line. I just have to keep following that over to here. So I went here and then down and then over. Okay. And that kind of gives me that best fit line, that blue line through the middle that kind of shows where the best fit would be. Okay. Now you can answer the questions. So we've done enough with the data now that you could just look at the questions on your lab sheet and answer those questions. You also are supposed to draw a picture of your graph and turn it in, which you are welcome to do on all this on paper if you would like. If you don't do it on paper, you can grab a screenshot right here and just paste this on your doc. You don't have to draw the graph. So that's one way to grab a screenshot, and then you can save that and add it to your doc or turn it in however if you can't get it on your doc, which you should be able to, it's pretty easy to do. You just insert an image on the sheet, which I gave you a copy of in the assignment in Canvas. So that's how you get a screenshot of this, and then you don't have to draw it. But it's up to you how you want to do it. If you need help, just reach out. Mr. 48 or myself can help you as well. All right, the questions it's going to ask you are things like, what type of relationship do you notice between the change in velocity, which we put down here on the x-axis, and the severity index? So look at what's happening as the change in velocity increases, okay? More velocity, more kinetic energy as you go from 3 up to 10. So as that increases, what happens to the severity index? So let's follow helmet 1. I'm going to click on it so all those dots are highlighted. And you can see that as severity increases, this is helmet 1, it had a change in velocity of 4.4, and the severity index was 11. As you go up, here's a change in velocity of 6.2, and the severity index went to 331. So 111 to 331, all tripled basically. Okay, let's keep going. You can look at each of these individually and observe what happens as we go all the way. This one is the farthest over on the change in velocity. I can't go any farther over on the x-axis, and it has a change in velocity of 9.1. The one above it here is 8.8. So this had the most change in velocity. 9.1 is the highest number for the helmet 1. And you can see the severity index is 692 here, down there. Okay. So that was the most change in velocity on the helmet. So the impact, the kinetic energy on that impact affecting that movement, and it had a severity index of 692. Let's look at helmet 2. So I clicked on the purple dot. They're all highlighted, and you can see that at low change in velocity, 3.9, severity index was 72. Let's go up here. Change in velocity, 6.3. So, okay, more kinetic energy in this impact and severity index was 347. Keep going up. So which one had the most change in velocity? This one. This one is the farthest over on the x-axis. It has a change in velocity of 9.1, and the severity index is 1,382. So let's go straight down to the green one. It also had a change in velocity of 9.1. Those were the same. So it was the same impact, but which one had more severe potential for damage to that player? Yeah, definitely helmet 2, because it had a much higher severity index. Okay, so look at that data. And what I find is the more I click on stuff and look at stuff, the more I understand it. Very few people look at this data or data sets like this and just instantly understand everything. It really takes kind of looking at things. So I hope this was helpful. Answer the questions on your assignment sheet and then turn it in when you're done. Okay, good luck.